Welcome Prep 1. Let's start our lesson today, Unit 1, Lesson 1, the set of rational numbers Q. We studied in primary stage some sets of numbers as number 1, the set of counting numbers C. It will be 1, 2, 3, 4, and so on. Then we have the set of natural numbers n. It will be C union 0. When we add 0 to the set of counting number, we will obtain a new set and it called natural number. It will be 0, 1, 2, 3, and so on. In primary 6, we studied the set of integer numbers Z. It will be 0 and positive numbers and negative numbers. By Venn diagram, we have C and Z positive plus 0, we will have a new set, natural number. Then, when we add the negative numbers, we will have Z, the integer numbers. So, counting numbers, subset of natural number, subset of integer numbers. And now, if you have a percentage like 30%, can you write it as a rational number? We can write 30 over 100. And in simplest form, it will be equals 3 over 10. Both of numerator and denominator belongs to Z, and the denominator not equal to 0. If you have a fraction like 2 over 8, it will be 1 over 4, a rational number. Or decimal number, negative 0.5, can put like negative 5 over 10, and in simplest form it will be equal negative half. So now the set of rational numbers Q equals the set of all numbers that can be expressed in the form of A over B, where A and B belongs to Z and B doesn't equal to 0. Q equals X, where X equals A over B and A and B belongs to Z, B doesn't equal to 0. And if you have an integer number like negative 6, we can put it like negative 6 over 1, a rational number. 0 equals 0, divide any number except 0. For example, you can put 0 in the form of 0 over 6 or 0 over any number except 0. What about 4 over 0? Can you divide any number by 0? No, I can't. So it will be meaningless or undefined. Now we have some different forms of rational numbers. First form, decimals. If you have a decimal number like 0.8, I can write it as 8 over 10. And in simplest form, it will be 4 over 5. Both of numerator and denominator belongs to Z, and the denominator doesn't equal 0. Number 2, a fraction. 2 over 14 is a fraction, and it will be 1 over 7 in simplest form. Third form, the percentage. Percentage means a ratio between two numbers and the second term of this ratio equals 100. You can write 25% like 25 over 100. In simplest form, it will be 1 over 4. Last form, the integer number. For example, 7. I can write 7 as 7 over 1. It's a rational number. We studied this Venn diagram before. Counting number or z positive, union the set of 0 equals natural number, and n union z negative equals z, all integer numbers. And when we add the fractions, the decimals, and percentage to all integer numbers, you will have the rational number q. So, counting numbers, subset from natural number, subset from integer numbers, subset of rational numbers. Now let's have some notes. Any integer can be expressed as a rational number in an infinite number of forms. For example, -3 is an integer number. I can write it as -3 over 1 or 3 over -1, and a rational number. Or -6 over 2, because 6 divided 2 equals 3. Or 6 over -2, and so on. But not all rational numbers can be expressed as integers. Be careful. For example, 2 over 3 is a rational and not integer. 0.7 equals 7 over 10. 7 can't be divisible by 10, so it will be rational and not integer. Second note, there are an infinite number of rational numbers between any two integers. For example, between 0 and 1. I can write, for example, 1 over 10, 2 over 10, 3 over 10 till I will find 9 over 10. And between 0 and 1 over 10, I can put more numbers. For example, between 0 and 1 over 10, I can find 1 over 100, because 1 over 10 equals 10 over 100. So I can write 1 over 100, 2 over 100, and so on. Number 3, if a over b equals 0, then a equals 0 and b not equals to 0. It means that any rational number equals 0 when the numerator equals 0. For example, 0 over 7. Remember, the denominator can't be equal 0. Number 4, if a over b is a rational number, then b not equal to 0. This from the definition of any rational number. 4 over 8 equal half, so b not equal 0. But 4 over 0, when we put 0 in denominator, it will be meaningless or undefined. So it must be b not equals to 0. I can put 0 in numerator, but not in denominator. From your booklet, let's solve sheet number 1. Write true or false. Letter A, 0 is neither a positive rational number nor a negative rational number. From primary stage, we studied before that 0 is an integer number, neither a positive nor negative, and still as it. 0, neither positive nor negative. It's true. Letter B, any integer is a rational number. Yes, we said that Z subset from Q. It will be true. Letter C, any rational number is an integer. No, that's false. Some rational number can be integer. For example, I can put 15 over 5. It will be a rational number. And 15 can divisible by 5, so it will be equal 3. It's an integer. But when we divide 15 over 4, it will be rational and not integer number. Letter D, if A over B equals 0, then A equals 0 and B not equal to 0. Yes, that's true. Any rational number equals 0 when the numerator equals 0. Letter E, if A over B equals 0, then B equals 0. No, that's wrong. We can't put 0 in denominator. Letter F, if A over B is a rational number, then A doesn't equal 0. No, I can put in numerator sometimes 0. It will be false. Letter G, if A over B is a rational number, then B not equal to 0. This is from the definition of Q. 1 over 3 is the natural number. In N, can you find the fraction? No, it's false. Can you find in N a negative number like letter I? Negative 3 is a natural number? No, we haven't a negative. 0 is a counting number? No, 0 doesn't belong to C. It will be false also. Number 2 in your booklet. Why does the definition of a rational number A over B state that B doesn't equal to 0? We can put 0 in numerator, but we can't in denominator. Why? Because any number divided 0 is meaningless or undefined. From your book, page 5, number 4, take this evaluation. Classify each statement as true or false. When a statement is false, tell why it's false. 1 over 3, the natural number. False. Why? In N, we can't find a fraction. Letter B, negative 1 over 3 is an integer. True or false? Yes, it will be false. In integer Z, we can't find a fraction also. 12 and 5 over 6 is a rational number. Rational number, any number can be written as A over B. 12 times 6 equals 72. 72 times plus 5 equals 77. I can write this number in the form 77 over 6. Rational number, both of numerator and denominator belongs to Z, and the denominator not equal to 0, so it will be true. Letter D, 6.5 is a rational number. Can you write in the form A over B? Yes, 65 over 10. It will be true. The number 0 is neither positive nor negative. It's so easy. Can you solve it? Yes, it's true. Last question. The number 0 is a counting number. 0 belongs to C? No, it's false. Complete. If 8 over A is a rational number, then A doesn't equal. The condition is denominator not equals to 0. So here A not equal to 0. Number 2, the number 3 over x minus 2 is a rational number if x not equal to. Here you can solve the equation in the denominator. X minus 2 equals 0 to find the value of x. X equals 0 plus 2 by using the inverse operation of subtraction. It will be 2. Number 3, the number 2 over 3x is a rational number if x not equals 2. In the denominator we have 3x. What the meaning of 3x? 3x means 3 times x. 3 times numbers equals 0. It will be also 0. The rational number 3 minus x over x minus 2 equals 0. If x equal, here we have a rational number equals 0. When the rational number equals 0? When the numerator equals 0. In this exercise, you will solve the equation in numerator. 3 minus x equals 0. So here x equal 3. Number 5. The rational number x minus 6 over x equals 0. Solve what? Which equation? Numerator or denominator? When he told you a rational number equals 0, look at the equation in numerator. So x minus 6 equals 0 when x equal 0 plus 6 equals 6. Another evaluation complete. If 7 over x plus 5 is a rational number, then x not equals 2. Negative 5. Yes. Number 2, 5 minus x over x minus 3 equals 0. If x equal 0, look at numerator. X equals 5. Number 3, 7 over x minus 3 doesn't belong to Q if x equal 3. The rational number 4 minus x over 5 plus x equals 0 when x equal 4. The number x plus 2 over x plus 5 belongs to Q if x doesn't equal to negative 5 by looking in denominator. And now from your school book exercise number 1. Use the number line to identify the opposite of each rational number in the table. We know that the meaning of opposite of this number is the same, it must be has the same distance. For example, the distance between half and 0 is the same distance between negative half and 0. Now I want to find the opposite of the rational number 3 over 2. Just change the sign. If the number is positive, so its opposite must be equal negative. So it will be negative 3 over 2. Now your turn. The opposite of the rational number 4 over 2 is? Okay. Next one, negative 5 over 2. It's a negative number, so its positive must be positive. Its opposite, must be positive. 5 over 2. 7 over 2. Negative 3 over 2. Negative 7 over 2. 2 over 2. Negative 6 over 2. 8 over 2. And number 2, complete the rational numbers on the number lines. In this number line, we have the denominator equals 3. So first number between -1/3 and -1 is -1 equals -3/3. Between -1 and -3 is -2. Between -4/3 and -2, we must put -2 with denominators 3, so it will be -6/3. Between -4 and -6/3, we have -5/3. In the right side, between 0 and 2/3, we can write 0 as 0/3. So between 0 and 2, we have 1/3. Between 1 and 5/3, 1 equals 3/3. Between 3 and 5, we have 4, will be 4/3. Second number line, the denominators equal 4. So between 0 and -2/4, we have -1/4. Between -2/4 and -1, we have -3/4. And we have -5/4 next to the number -1. In the right side, between 1/4, 3/4, yes, 2/4. The next number after 1 equal 4/4, so it will be 5/4. Next, 6/4. And now we have different forms of the rational number a/b. We know the percentage from primary 6. Rational numbers can be written as a percentage as half by multiply up and down by 100. It will be 50%. One over 4 equal, we can multiply by 100%, equal 25%. 3/4 times 100% equal 75%. 1/5 equal 20%. 2/5 equals 40%. 6/5 equal 120%. So if you want to write from a fraction into percentage, you will multiply by 100, and if you have a percentage want to convert into decimal, must be divided by 1. Another form, we have terminating decimals. Some rational numbers can be written as terminating decimals, like 1/2 by multiply up and down by 5, it will be 0.5. We studied in primary stage best friends. 2 times 5 equal 10. 4 times 25 equal 100. 8 times 125 equal 1000. And we have another numbers. Infinite repeating or recurring decimals. Some rational numbers couldn't be changed in terminated decimals. Then when we use calculator, we find that 1/3 equal 0.3333. It must be written in the form 0.3, and above 3 you can write this point. This is a recurring number. 2 over 11 by using your calculator, it will be 0.18, 18, 18, 18, and so on. So you will put point above 1 and 8. But if you have 5 over 27, it will be 0.185, 185, 185. We have 3 digits here repeating. Write 0, decimal point, then 1, above 1 we have a point, then 8, 5, above 5, point. So if we have 3 repeating digits, we will put the point in the first number and the last number only. And this means this 3 digits is repeating. The point above the digit means that it's repeating. From our booklet, write each of the following numbers in the form of terminating decimals using best friends. 5 is the best friend of 2. Up and down, it will be 4 over 10. By decimal, 0.4. If the denominator equals 25, best friend of 25 equals 4. So up and down it will be 24 over 100. It will be 3.24. Letter E, negative 11 over 20, best friend of 20 equal 5. So it will be negative 55 over 100. Write each of the following numbers in the form of percentage. 9 over 20 by multiply by 100, it will be 45%. 9 over 125 times 100, it will be equals 7.2%. If we have a decimal number, 2.5 multiplied by 100, it will be 250%. Use your calculator to write each of the following numbers in the form of rational number. We have a recurring number and the point above 6. So, by using your calculator, how you can write this in your calculator? You will put 0, decimal point, and 6, 6, 6 till our screen is full with numbers, and you will see an arrow equal. It will be 2 over 3 in a rational number. 5.213 and 2, above 2 we have a point, above 3 we have a point. It means you will write 5, decimal point, 213, 213, 213 till our screen will full with numbers. When I see the arrow in the screen, click equals, it will be 1736 over 333. Write 3 rational numbers expressing each of the following rational numbers. For example, if you have 5 over 7, I want 3 rational number equal 5 over 7. You can multiply this number up and down by 2 or by 3 or by 5 or by 10, any number except 0. For example, multiply up and down by 2, it will be 10 over 14. Or multiply up and down by 3, it will be 15 over 21. Or by 4, it will be 20 over